Hey, geometry students. In this lesson, we're going to be talking about two special kinds of angles that we measure in geometry. One is called an angle of elevation, the other is called an angle of depression. The reason that these angles are special is because they're super functional. We can use these in real life. It's really easy to measure angles of elevation and angles of depression, so these will oftentimes be used to measure the heights of real world objects. An angle of elevation is the angle formed from a horizontal line and a line of sight to the point above. So just take a look at this guy looking at this bird in this image here. Notice that there's a horizontal line that goes horizontal with respect to the surface of the earth, and then he's looking above the horizontal line. If we measure between his line of sight and this horizontal line, that's an angle of elevation. Angle of depression is kind of the same sort of thing. An angle of depression is any angle that makes you sad. Um, Actually, what it really is if you're standing at the edge of a cliff looking down, we can measure the horizontal line at the edge of that cliff. It's going to be horizontal with respect to like the surface of the earth. And then your angle looking down below, your line of sight down below, the angle between your line of sight and the horizontal would be an angle of depression in that case. Or in this case, from the bird's perspective, looking down at the person from the horizon to the line of sight is an angle of depression. Now, we're going to find is that because we're dealing with horizontals, and you're going to find that in these problems, we're also going to be dealing with verticals. Horizontals and verticals are always perpendicular to each other. So because we have perpendicular horizon vertical, we're going to have a right angle, and that's going to make right triangles. So we're going to be able to use right triangle trig in this lesson: sine, cosine, tangent. And that's what you're going to see that this lesson is all about. Okay, let's get started on the practice. Letter A. Standing 300 feet away from a building, the angle of elevation to the roof is 67 degrees. Find the height of the building to the nearest foot. Okay, so for these problems, we're going to need to make a little diagram. We're asked to find what the height of the building is. Wait a second. The height of the building is a vertical. It's going to be this side. So we're going to say that this is x feet. Okay, now, do I have a trigonometric ratio that for a right triangle relates this bottom side to this far side if this is a 67-degree angle? Hey, I'm just going to note something here. This angle in my triangle is not realistically 67 degrees. I'd have to make this triangle look a lot more like this. So let me just fix my triangle here. Doesn't have to be perfect. It doesn't really have to match up because the math is still going to work out, but it's probably best to make it look as realistic as possible, just so my answer doesn't come out of left field and surprise me. Okay, so the way that I'm going to work this one is with a trigonometric ratio that relates the adjacent side, which is the side that touches the known angle, but not the hypotenuse, okay, to the opposite side. Ooh, do I have a trigonometric ratio that relates opposite and adjacent? Well, if I think about it, SOHCAHTOA, one of these SOHCAHTOA ratios should have an opposite and adjacent in it. It's TOA. So that means, so if I write that one out, it's going to be the tangent of x. In this case, x is 67 degrees. It's always the tangent of an angle. The tangent of your angle equals, let's see, the opposite side. Well, the opposite side is the unknown. So I'm going to put x over the adjacent side. My adjacent side is 300 feet. So that's what I'm going to plug in for adjacent. And then I should be able to solve this. So the tangent of 67 equals x over 300. The tangent of 67 is just some number. It's a ratio. How many x on a side by itself? I need to multiply both sides by 300. It's going to be 300 times whatever the tangent of 67 is. So I'm going to take a calculator. I'm going to note that my calculator needs to be in degree mode, not radian mode. And then I'm just going to do the multiplication. So it's going to be 300 times the tangent of 67 to get x on a side by itself. So I'm just going to type that in. 300 times the tangent of 67, and it's in degree mode, so I know it's calculating in degrees. I get 707 feet. 707 feet. All right, let's move on to the next one. And what we're going to do is just redraw another triangle down here for letter B. But this time we're going to be dealing with an angle of depression. And actually, I don't even know that we need to make our own triangle. We might just be able to use the triangle that's in the diagram or adjust this triangle in the diagram. So what I need to do is think through what it is I'm looking for. A family sees their house from a window of a tall building. It's 160 meters up above the ground. So if this is their house, that means that this height here is 160 meters. Okay, that's noted over here. This is a right triangle. And what I'm looking for in this diagram is x, the horizontal distance from the building to the house. Okay, so I need to figure out what this x value is in this diagram up here. It looks like, though, if I know that this is 160, I might as well just put that in the diagram too, just to clarify things. So we'll just put 160 meters over here. If that side is 160 meters, it should be pretty straightforward. Let's see. So here I know this angle. X is my adjacent, and then 160 would be the opposite from that angle. Again, I know opposite and adjacent, so this one's going to be just like the last one, a tangent problem. The tan of 55 degrees. Now let's be careful to make sure we get things in the right spot here, equals the opposite side over the adjacent side. This time I know the opposite side is 160 over the adjacent side, x. That's my unknown. Okay, now notice my unknown is in a different spot here. In the previous problem, my unknown was in the numerator on the right-hand side. That was really easy to solve. In this one, it's actually in the denominator on the left-hand side, which makes this one just a little bit harder. So what I'm going to do is I'm actually just going to go through and multiply both sides by x. I'm going to see that x times the tangent of 55 degrees equals 160. Or if I divide both sides by the tangent of 55 degrees, because it's just a number after all, tangent of 55 is just a ratio, just an actual number that my calculator will give me. So I'm going to say that x equals 160 over the tan of 55. Okay, and that should give me my answer of how far away my house is. So let's see if we can do that. 160 over the tan of 160 over the tan of 55. There we go. Just double check and make sure I'm still in degree mode. I am. 112. So we're about 112 meters away from our house in this one. Let's just double check and make sure that's correct. There we go. Jocelyn sees a hot air balloon at an angle of elevation of 30 degrees. Anthony sees the same hot air balloon at an angle of elevation of 50 degrees. The balloon is 140 meters off the ground. They are starting on the same side of the balloon. How far apart are Jocelyn and Anthony to the nearest meter? We are going to have to solve two right triangles to figure this one out. So it's going to be angle of elevation, and we're doing 30 degrees and 50 degrees. Okay, so here's what we know. We know that Jocelyn and Anthony are at different distances from each other. One of them is seeing the balloon here. The balloon isn't changing its height, but one of them is closer to the balloon than the other. Okay, so this would be like Jocelyn's position, I believe. Wait, no, this will be Jocelyn, way far away at 30 degrees. And then Anthony's closer. He's seeing it at like 50 degrees. Okay, so let's put our known values on here. We're going to put for Jocelyn, this is 30 degrees. That would be nice knowing that it's a 30, 60, 90 triangle, except, and it is nice to know for Jocelyn, except I know that Anthony's triangle is not going to be a nice triangle. It's a 50-degree triangle, which is not one of our special triangles. So the other thing that we know is that the balloon is 140 meters up off the ground. So what I'm going to do is I'm going to see if we can figure out the distance along the bottom for Jocelyn, the distance along the bottom for Anthony, and if I subtract those two, I'm going to get the distance that they are apart. All right. So that's going to look like this. Let's just work our problem over here. Letter C. So the tan of 30 is going to be the opposite side, 140 over. I'm going to use J for Jocelyn and A for Anthony. Okay. The tan of 50 is going to equal 140 over A for Anthony. Okay, and I can solve both of these. Actually, both of these are, let's see, opposite over adjacent. So these are the hard ones to solve where I'm dividing by my variable. So what I have to do in these is multiply both sides by J. J times the tangent of 30 equals 140, or 140, this is going to be 140 over the tan of 30. That's going to give me Jocelyn's distance. So that's 242.5 meters. I'm just going to keep that extra 0.5 in there for now. So it's Jocelyn is 242.5 meters. Anthony is going to be 140 over the tangent of 50. So let's do that. 150 over the, I'm sorry, 240 over the tan of 50. Let me just double check. 240? 140. It is 140. For some reason, my brain jumped to 240. Okay, 140. 140 over the tan of 50. There we go. So Anthony is 117.5 meters away. Okay, and now the question is, how far away is Anthony from Jocelyn? Well, all I need to do is subtract these two numbers. So 242.5 minus 117.5. Let's see. 242.5 minus 117.5. 125 meters apart. So we're just going to write that as our answer, and we'll see if that's correct. 125 meters apart. And let's see if we did that correctly. Let's see. I think the answer is there. 125 meters apart. Who is farther away from the balloon? We knew that was Jocelyn the entire time. All right. Lastly, a surveyor on top of Blake Hill measures an angle of depression of 16 degrees to the top of Pike Hill. The height of Blake Hill is 400 meters. The height of Pike Hill is 300 meters. What's the distance between the hilltops to the nearest meter? Now, here's what you need to do. We need to find this little height of this right triangle here that's pictured. If this is 400 and this is 300, do you see what this little height must be? That's right. It has to be 100 meters. Okay. Now, I can use, and what am I looking for? I'm looking for the horizontal distance between the two. That's right. Once again, we are going to use tangent. And I'm going to set up our problem over here. This one's going to be letter D. The tangent of x, in this case, x is 16 degrees. Okay, that's an actual number that the calculator knows. The tangent is 16 degrees equals the opposite over adjacent. Opposite side is 100. The adjacent side is x. I'm going to multiply both sides by x to get x on a side by itself. I'm going to multiply both sides by x first. So we have the tan of 16x equals 100, or x equals 100 over the tangent of 16 degrees. All right, let's go back to our calculator, and we're going to do 100 divided by the tangent of 16 degrees. And we're going to get 349 rounded to the nearest whole meter. X equals 349 meters. And that is how you work elevation and depression problems. You should be able to do the next problem set for next time.